Welcome to my channel. NASA has announced that its Voyager 1 probe, the most distant man-made object in the universe, will once again send usable data back to Earth. The exact nature of this information remains unknown, but it can be measured. Voyager 1, NASA's iconic space probe launched more than 4.5 decades ago, recently returned a signal that sent shockwaves through the scientific community. After traveling nearly 14 billion miles from Earth, Voyager 1 made such a profound discovery that it changed its mission and returned to our planet. But what exactly is this discovery? Could this be evidence of extraterrestrial life, a cosmic anomaly, or something yet to be understood? To understand the significance of this important event, we must first look at the history of the Voyager probes. If certain celestial events had not lined up, these remarkable spacecraft may never have left Earth. About 60 years ago, the four largest planets in our solar system entered a rare pattern last seen during Thomas Jefferson's presidency in the early 1800s. At first, this planetary alignment went largely unnoticed, but Gary Flandreau, a doctoral student in aeronautics at Caltech, recognized its significance in 1965. Working part-time at NASA's Jet Propulsion Laboratory, Flandreau was tasked with finding the most efficient way to send a space probe to Jupiter or from there to Saturn, Uranus or Neptune. He carefully plotted the orbits of these giant planets and noticed that in the late 1970s and early 1980s, all four planets were lined up to be visited by a single mission. This alignment meant that the spacecraft could use the gravitational pull of each planet to fly to the next one, greatly reducing travel time. Flanders calculated that this alignment would reduce the flight time from Earth to Neptune from 30 years to only 12 years. However, this planetary alignment only happened once every 176 years. To take advantage of this rare opportunity, the spacecraft would have to be launched in the mid-1970s. NASA seized this once-in-a-lifetime opportunity and built two spacecraft for the journey, Voyager 1 and Voyager 2. On September 5, 1977, Voyager 1 launched from Cape Canaveral, Florida, and Voyager 2 launched only 15 days earlier, on August 20, 1977. Both spacecraft sent an incredible mission to explore the outer planets of our solar system. Thanks to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of Voyager's twin probes marked the beginning of pioneering research. Voyager 1 began its epic journey into space aboard the Titan IIIe rocket. Both Voyager 1 and Voyager 2 were tasked with studying giant gas giants like Jupiter and Saturn and their many moons. They far exceeded expectations, traveling farther and longer than any other spacecraft in history. They entered the region known as interstellar space, a completely unexplored region of our galaxy. Today, Voyager 1 and Voyager 2 are more than 12 billion miles from Earth and continue to amaze scientists with their remarkable discoveries. The Voyager probes have achieved several notable achievements over the years. They studied the moons of Jupiter and Saturn, revealing real worlds rather than the dull and stained surfaces originally believed. Voyager 2 made history by being the first spacecraft to visit Uranus in 1986 and Neptune only 3 years later. Despite its achievements, Voyager 2's achievements were overshadowed by the tragic explosion of the Space Shuttle Challenger shortly after its closest approach to Uranus. Voyager 1 reached Jupiter in March 1979 and Voyager 2 in July of the same year. Both spacecraft were equipped with Vidicon cameras that captured full-color images and provided excellent views of the planets and their moons. For example, a cracked ice crust has been observed on one of Jupiter's moons, Europa. The spacecraft used Jupiter's gravity launcher to propel it into interstellar space. Voyager 1 continued its journey, passing through the rings of Saturn and flying past Titan, a moon shrouded in an orange haze. Voyager 2 ventured to Uranus and Neptune, discovered a new moon and added the planet to the list of ringed worlds. Voyager 2 also encountered Neptune's fastest winds and coldest temperatures, as well as icy volcanoes on Neptune's largest moon, Triton. After sending back stunning images of Neptune and its moons, both spacecraft had to turn off their cameras, marking the end of their official mission. But the astronomer Carl Sagan convinced NASA to continue the mission. On Valentine's Day 1990, Voyager 1 turned its camera back toward the inner solar system and captured the famous pale blue spot image, in which Earth appears as a tiny dot against the vastness of space from an astonishing 3.8 billion miles away. In August 2012, Voyager 1 reached an incredible milestone by reaching beyond the heliosphere, the vast region of charged particles emitted by the Sun. The discovery was widely recognized the following year, when a study published in the journal Science showed that Voyager 1 had entered a region of higher particle density than the interior of the heliosphere. Scientists have set the launch date as August 25, 2012, the same day Apollo 11 astronaut Neil Armstrong died. Voyager 1 observed a significant decrease in solar particles and an increase in galactic cosmic rays. The Voyager flights played a crucial role in shaping our understanding of space. They pioneered gravity-assisted movements and laid the groundwork for future research. The Deep Space Network, DSN, a global network of radio antennas, has been essential in communicating with the Voyager probes as they head into the unknown. The DSN, with its extensive array of radio antennas, acts as a cosmic telephone line that keeps us in touch with these terrifying spaceships.